In this question, we are given that the letters in the table, it represents the numbers 1, 2 or 3. And we have given that each of these numbers, they occur exactly once in each row and exactly once in each column. That means that if 1 is present in the first row, then 1 cannot occur in this part of the row and in this part. Similarly, 1 cannot also occur in this part of the column. So this is what the question means. So we can conclude the same thing for the other numbers as well. Since there is not much that we can infer from the question, we move on to step 2. Now in step 2, we analyze the statement 1, which tells us that v plus z gives us 6. Now when is this possible? This is possible only when the values of v and z are individually 3, such that they add up to give us 6. So, if v is equal to 3 and z is also equal to 3, and since 3 has to occur exactly once in each row and each column, that means this row cannot contain any more 3, this column cannot contain any more 3, and this column as well. Similarly, this row already has 1 3 and the last row also has 1 3. So the only option left for the number 3 to be present in row 1 is in the square of r. So we can conclude that the value of r will be equal to 3 here. So we can conclude that statement 1 is sufficient. And from the given options, we eliminate B, C and E. We now check the sufficiency of statement 2. In statement 2, we are given that the sum of S plus T plus U plus X, that is equal to 6. If I take S and T to be individually 3 and 3, U and X will have to be 0, which is not possible. So, what if I take S to be 3 and T to be 2? We would have to add up 1 and 0. So, this case is also not possible. From this we know that S, T, U and X are not 3. None of the letters is equal to 3. So, how can we add up these 4 letters to get the value 6? Now, this is only possible when the value of S can be 2, T is equal to 1, U is equal to 2 and X is equal to 1. So in the table here, we have S is equal to 2, T is equal to 1, U is equal to 2 and X is equal to 1. Now, some of you might take the value as T is equal to 2 and U is also equal to 1. But keep in mind, when you substitute these values, if we put T as 2, then the same row, that is the first row, will have 2 2's, which is not possible. So the value of T has to be equal to 1. And the order of 2 and 1 can change. That means S can have the value 1 and T can have the value 2. Because the order doesn't really matter. We just have to keep in mind that the numbers should occur exactly once in each row. So if we add these two up, add all S, T, U and X, they give us 6. So the only option for R is to be 3. Using the statement 2 also, we can conclude that R is equal to 3. Statement 2 is sufficient. So the correct answer is option D.